segments of the transversals that are cut off by parallel lines are going to be cut off proportionally. What that means is that the ratio of A to B is going to equal the ratio of Y to Z. The corresponding ratios, or the corresponding segments of the transversals that are cut off, are going to be cut off proportionally. Okay, so what that would mean is if we had a third transversal come through here with, let's say, S and T, then that ratio will also hold true. The ratio of S over T is the same as A over B or Y over Z. Okay, so you're going to see this kind of embedded or built in a problem. Okay, the simplest of which might simply be you're given 3 of the pieces of information and you're lacking 1. So if you were told that these were parallel lines, okay, one of the easiest ways to look at this and approach it is the figures themselves basically set up the proportion. If you just think of the parallel lines as being a fraction bar, and you set them equal, you get your ratio. 7 over 21 is equal to Y over 15. And then it's just a matter of solving. So if we multiply both sides by 15, 7 goes into 21 3 times, 3 goes into 15 5 times, so you get Y is equal to 5. And you can test it and see, is the ratio of 7 over 21 equal to 5 over 15? Yes. Okay. All right, try this one on your own. So again, the easy way to set this up is just visually. When you look at this problem, you could just create your fraction bars, put an equals in between, and you have your proportion, in which you can then just solve. So x over 10 is equal to 3 over x plus 13. And then solving this, you can cross multiply. X times x plus 13 is equal to 10 times 3. Distribute your x through and get x squared plus 13x is equal to 30. If you recall from algebra, anytime you're working with a quadratic equation, you move all your terms to one side. And then look to factor. Set your factors equal to 0 and solve by using the zero product rule. So the two factors of negative 30 whose sum is positive 13. And remember, the signs have to be opposites since the product is negative 30. When you look at the factors, so the factors have to have a difference of 13. The larger of them needs to be positive. So that is 15 and 2. Which means when you use the zero product rule, set each of these factors equal to 0. X is either negative 15 or x is 2. So if you test that back in, can your x value, can your distance be a negative number? No. So this is an extraneous solution. It means it does not fit back into the restrictions of the problem itself. But let's test 2. Is it true that 2 over 10 is equal to 3 over 15? Yeah, they both reduce to 1 over 5, and so you get your solution to be 2.